Good morning. In this video, we will look into some deadlock exercises. That is the resource allocation graph and checking whether there is a presence of deadlock or not. Okay, let's see the question. There are three processes and two resources. Normally the processes we call them, we name them like P1, P2, P3, three processes and two resources, something like R1, R2. Let's assume we are going to refer by this name. So let's say resource R1 is assigned to the process P1 and P1 is waiting for another instance of a resource R2. And one instance of resource R2 is assigned to P2 and P2 is waiting for a resource R1. Okay. And there is another instance of resource. So one other instance of resource R2 is assigned to P3. So this is the idea of the situation, the three processor and the two resources. So the question is, draw the resource allocation graph and we are going to check for the presence of deadlock. Okay. So first we need to draw the resource allocation graph. Okay. So the question clearly says there are three processes and two resources. So let's say resource 1. Remember resources, we are going to use the rectangle notation. Okay. And for process we are going to use the circle notation. So how many processes we have? P1, P2, P3. So let's say P1 and you have P2, P3. So let's assume this way. So first you draw the nodes, resource and then the processes. You know, in the question it clearly says one instance of R2 is assigned to somebody, another instance of R2 is assigned to somebody. So that means to say you have two instances of R2. So you just put a 2 dot. 2 dot here, it represents two instances. So R1 is having only one instance. Here I write the R1 inside the rectangle sign. If you want, it's better you write it outside so that the dot will be clear enough inside the box. Okay. So let's see the question. Resource R1 is assigned to P1. Resource R1 is assigned to P1. So the direction should be from the resource to the process. It's assigned to P1 and P1 is waiting for R2, waiting. So it should come from process. Okay, when a edge comes from a process to a resource, it means the process is requesting. When an edge comes from a resource to a process, it means it is already been assigned. Okay, and the next one instance of resource R2, this is R2, is assigned to P2. So one instance is already assigned to P2. It goes like that. Okay, and then P2 is waiting for R1. So here this P2 is waiting for R1. So it goes like that. It means it is requesting. Waiting means P2 is requesting. Okay, for this resource R1. And one instance of resource R2 is assigned to P3. So this one instance is assigned to P3. Okay, P3 is not waiting for anything. Can you see here? P3 wants only one resource that's been assigned already. So we already draw the resource allocation graph. Now we need to check for deadlock. So let's draw a table which is going to record the allocation of the resource and the request of the resource by three processes. So we have process P1 and then P2 and then P3. So there are three processes we have. So let's see what are the request it's made and what are the allocations. So let's see the question one more time or the diagram one more time, whatever. Resource R1 is assigned to P1. Okay, so resource R1 is assigned to P1. Okay, that is the meaning. One means it's been assigned. Okay, and P1 is waiting for resource R2. P1 is waiting. Waiting means it's requesting. So P1 is waiting for resource R2. So when I write a 1 under the resource, it means it is resource allocation. R1 is allocated to P1. R2 is not allocated. So just put a 0. And this entry is for request. P1 made a request for R2. It's waiting for R2. It's not waiting for R1. So I put a 0. So this is the first one. Let's see, continue the question. One instance of R2 is assigned to P2. So the allocation, one instance of R2 is assigned to P2. So R1 is not assigned. And the question says P2 is waiting for R1. P2 is waiting for R1. Okay. So P2 is waiting for R1 and 0 means it's not requesting R2. Here 0 means the R1 is not assigned to P2. Okay. This area is for allocation and this is for waiting. The process is waiting for what? Requesting for which resource. Okay. And now one instance of R2 is assigned to P3. So one instance of R2 is assigned to P3 and R1 is 0. And the question doesn't say anything about the request. P3 is not requesting for any resource. It is not waiting for any resource. So this table, the resource allocation table and resource request table, when you draw this, you can able to easily identify is there a deadlock or not. Okay, let's look into the situations what are the resources assigned, what are the processes available here, what are the resources are being requested. When you look into that, let's see here the available resource here is 0 for, sorry, just a second. Okay, now the available resource, let's figure out. So what is the available resources here? Can you see from the here allocation? From the question, there is one instance of R1, it's been assigned, and there are two instances of R2, the two instances were assigned. So what is the resource available? 0, 0. That means R1, the first 0 is about R1, the second 0 is about R2. So 0 resource, 0 instance of R1 is available, 0 instance of R2 is available. That is, none of the resources is available. Okay, so this is the available resource. Let's check the P3. Let's closely check the P3. P3 is assigned with R2 and it's not requesting anything. Can you see here resource request? P3 doesn't request any resources. So P3 will complete the process. So process P3 will complete the execution. After execution, you already know that after execution it will release the resources allocated. So what it will release? It will release resource R2, one instance of resource R2. So after that, what will be the available resource? So after the execution of P3, available resources will be, because it releases R2. So one instance of R2 is available, R1 is not available. So 0 and 1. This is R1 and this is R2. One instance of R2 is available and 0 instance of R1 is available. Okay then. So with this available resource, among the P1 and P2, which one can be executed? See, P1 wants R2. P2 wants R1. I have one instance of R2. So which one can be executed? Process P1. Because P1 needs R2. Here I have a available resource R2. Can you get the idea? So one instance of R2 will be assigned to or allocated to P1, and it will finish execution. It will complete the execution. After the completion, what it will do? You know already, when a process finishes the execution, it will release the resources allocated. So it will release both R1 and R2. Okay then. So it will release R1 and R2. Fine. So when it releases R1 and R2, the available resources will be available resources. It will release R1 and it will release R2. So 1, 1. Okay then. So now let's see, you have one instance of R1 and one instance of R2. So how about the process P2? It wants R1 only. So one instance of R1 will now be assigned to P2 and it will complete the execution. After the execution, of course, it will release the resources. So which is R1, one instance of R1 and one instance of R2. So the available resource, so what are the available resource? One instance of R1, and then can you see here, this one instance of R1 is given here, okay, which was the one assigned to P2 will be released. Can you get the idea? And two instances of R2. Okay. So one instance of R1 and two instances of R2. So this is the available resources. So as a conclusion, all the three processes were executed smoothly. So you can see that there is no deadlock. So there is no deadlocks. Can you get the idea? Even though you see a cycle, don't think that there is a cycle means there is a deadlock. Can you see the cycle here? R1 is assigned to P1, P1 is requesting R2, R2 is assigned to P2, P2 is requesting R1. So when you see a cycle, you may think that there will be a deadlock, but because of the other instance of R2, the deadlock situation is not happening. Okay, so this is one example. Let's see another example of resource allocation graph and checking the deadlock. Can you see here? Resource R1 is assigned to the process P1 and P1 is waiting for the resource R2. And one instance of resource R2 is assigned to P2 and another instance is assigned to P3. And P2 is waiting for R1, P3 is waiting for R2. P3 is waiting also for R1. Okay, so this is the situation and we are going to draw the resource allocation graph and we are going to check for situation, deadlock situation. So this is the question. So let's see how does it work. So there are same situation, three processes and two resources. As I mentioned, so resource, I am going to use the rectangle sign. So I am going to put that outside for clarity. And for R2, we already know from the question, there is two instances of R2, one instance of R1. Again, we have three processes, P1 and then P2 and then P3. Circular notation for the process, rectangle notation for the resources. Okay. Question says resource R1 is assigned to process P1. So this is the edge for allocation. P1 is waiting for R2. So P1 is waiting for R2. When the resource is being assigned, the direction should be from the resource to the process. When a process is waiting or making a request for a resource, the edge from process to the resource. Okay. One instance of resource R2 is assigned to P2. Here it is. And another is assigned to, one instance of resource R2 is assigned to P2 and another instance is assigned to P3. Okay. And P2 is waiting for R1 like this. This is waiting. Even P3 is also waiting for R1. So P3 is also waiting for R1. Can you get the idea? So which resource is assigned, which resource is not assigned, you can see from the graph. But anyway, let's see the allocation table. So there are three processes, P1, P2, P3. From the diagram, we can easily say that P1 is assigned with R1, P2 is assigned with R2, this is P3. P3 is also assigned with R2. Okay, resource request. P1 request R2, P2 and P3 request R1. Okay, so from this graph, what is the available resource? So the available resources is 0, 0. So none of the resources available. This is R1, this is R2. See, one instance is there, it's been already assigned to P1. There are two instances of R2 that's also been assigned to P2 and P3. So none of the resource is available. Both are 0 means not available. Okay, and let's see the request. So the request, resource request from the diagram. When you see the resource request, if it is 0 and 0, the process can continue execution. Okay. But the resource request here is what? For P1, 0, 1. For P2, 1, 0. And for P3, also the same. So the resource request is 0, 1, 1, 0, 1, 0. So you cannot fulfill any of the requirement. We can't fulfill because there is no available resource. But P1 is requesting for R2, P2 is requesting R1, P3 is also requesting R1. Can you see from here? But available resource is 0, 0. So there is deadlock because, there is deadlock because none of the resources available and the resource request, the processes are requesting the resources. So we cannot fulfill any of these resource requests. So there is a deadlock. Okay.